Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0717, indicates an issue with the continuously variable transmission, CVT, input shaft speed sensor A circuit. Specifically, that it is receiving no signal. This sensor is crucial for monitoring the speed of the drive pulley within the CVT system. Its primary function is to provide real-time data to the Powertrain Control Module, PCM, for smooth operation and optimal performance. The sensor is located close to the torque converter within the transmission assembly, which makes it essential for accurate transmission functionality. When the sensor fails to send signals, it affects the overall vehicle performance and may potentially lead to transmission issues. The vehicle's onboard diagnostics detects this malfunction during its self-checks, leading to the illumination of the check engine light on the dashboard. The DTC P0717 describes a breakdown in the circuit that connects the CVT input shaft speed sensor A back to the PCM. This disconnection or malfunction means the PCM is unable to receive necessary speed data from the transmission system, which is vital for making adjustments to improve vehicle ergonomics and performance. The sensor's role is to report the rotational speed of the input shaft, which directly influences the vehicle's gear selection and drivability. Its physical location is integral as it sits adjacent to the torque converter, deep inside the transmission area. Regular functionality of this sensor is crucial, as its failure can lead to erratic shifting, poor acceleration, and potentially damage the transmission. A diagnostic readiness check will often confirm DTC P0717 if the sensor has a persistent issue. When diagnosing DTC P0717, several potential causes must be identified. The foremost cause is usually attributed to an electrical circuit failure, indicating that there may be an issue with the wiring or connectors linked to the torque converter turbine speed sensor. This issue could manifest as pinched wires, corrosion, or disconnections that interrupt the signal flow. Another possibility is a faulty torque converter turbine speed sensor itself, which may require replacement if it is not operating correctly. Poor connections, such as loose terminals or corroded contacts at various points in the circuit, can disrupt the signal transmission, leading to the code being triggered. Each potential cause has implications for the sensor and how the vehicle interprets speed data, which in turn affects the overall performance of the transmission. The symptoms associated with DTC P0717 often make themselves known through noticeable changes in vehicle behavior. The most immediate and prominent symptom is the activation of the check engine light, alerting the driver to an underlying issue. Additionally, erratic transmission behavior may occur, evidenced by unexpected shifts or difficulty in engaging gears smoothly. Drivers might also experience a loss of power during acceleration, as the decreasing effectiveness of the torque converter affects overall performance. Other less common symptoms might be engine stalling or unusual noises from the transmission compartment, as it struggles to operate without proper input from the sensor. Understanding these symptoms can guide the technician in identifying the appropriate course of action in addressing the fault. The first step in troubleshooting DTC P0717 involves confirming the error's presence and checking basic vehicle operations. Initially, the technician should turn the vehicle to the on mode, which powers up the electrical systems without starting the engine. Following this, clearing the DTC using the Honda Diagnostic System, HDS, is crucial to reset the system and gather fresh data. Once cleared, the vehicle should be elevated securely on a lift to allow for testing while ensuring the wheels can rotate without obstruction. Then, the technician will start the engine and enter the Vehicle Stability Assist (VSA) maintenance mode for more comprehensive diagnostics. Finally, the vehicle must be driven at speeds exceeding 19 miles per hour for at least 30 seconds before stopping to check for any confirmed or pending DTCs with the HDS again. This step ensures that any ongoing electrical issues can be faithfully replicated. In the second troubleshooting step, the technician will turn the vehicle off completely to ensure safety before disconnecting the torque converter turbine speed sensor's 3P connector. This disconnection is crucial as it isolates the sensor for testing. With the connector removed, the vehicle is turned back to the on mode without starting the engine, allowing for the measurement of voltage across specific test points. The main goal here is to evaluate if the voltage between test points, specifically between the sensor terminals and body ground, demonstrates approximately 5 volts, which indicates a successful power supply to the sensor. If the voltage is present, it directs attention towards the next step in checking for potential wiring issues. If not, further inspections on the wiring and connectors between the sensor and the PCM need to be initiated. Step 3 of the troubleshooting process involves an open wire check on the VCC2 line. With the vehicle still in the on mode, and after confirming disconnection of the torque converter turbine speed sensor, the technician measures the voltage again, but this time between different test points, specifically targeting the number 3 terminal of the sensor 3P connector and a reliable body ground. The goal here remains to find that approximately 5 volts, confirming that the voltage condition continues along the wiring leading from the torque converter to the PCM. If this voltage is present, the system is likely intact, and the technician can proceed to check the sensor functionality in the next step. However, if the voltage is absent, it signals an open circuit in the VCC2 wire, necessitating repairs before further testing can continue. During the fourth troubleshooting step, the voltage measurement check will focus on assessing the functionality of the torque converter turbine speed sensor directly. The technician will measure the voltage between the number 1 and number 3 terminals of the sensor, while ensuring the 3P connector remains disconnected. A voltage reading of around 5 volts indicates that the sensor is likely functioning correctly. If this is confirmed, it necessitates replacement of the torque converter turbine speed sensor to resolve the persistent DTC P0717. However, if the measured voltage is not around 5 volts, this suggests an open in the SG2 wire leading back to the PCM, and appropriate repair actions need to be executed. Following this step will help preserve optimal vehicle operation by replacing or repairing faulty components as necessary. In the fifth step of troubleshooting DTC P0717, a detailed check for any shorted wires within the NT line is conducted. First, the vehicle must be switched off completely, and the SCS line should be jumped using the HDS, protecting the powertrain control module from potential damage during testing. With the vehicle shut down, the technician disconnects the PCM connector C51P to provide access for testing continuity. During this process, continuity is tested between the torque converter turbine speed sensor's number 2 terminal and body ground. If continuity is confirmed, this indicates a short to the body ground within the NT wire between the sensor and the PCM, demanding immediate repair. If no continuity exists, the technician can move on to the next troubleshooting step to ascertain the wire's integrity further. The final troubleshooting step focuses on confirming continuity within the NT line between the torque converter turbine speed sensor and the PCM. With all relevant connectors disconnected and the vehicle in the off mode, the technician will measure the continuity between the sensor's number 2 terminal and the designated number 21 terminal in PCM connector C. This step is imperative to check the integrity of the NT wire. Confirmation of continuity suggests that the wiring is intact and capable of transmitting signals. If continuity is established, then the subsequent course of action would be to consult any relevant authorized service information about DTC P0717, or potentially replace the original PCM if it's determined to be defective. If no continuity is detected, repairing the open in the NT wire becomes paramount to restore functionality and clear the DTC from memory. The final repair verification process for DTC P0717 involves carefully reassembling all previously disconnected connectors to ensure that no component is left unconnected, creating yet another point of failure. After all connectors are securely fastened, the next step is to clear any remaining diagnostic trouble codes, DTCs, using the HDS, thereby resetting the vehicle's onboard computer system. This reset allows for the validation of any repairs made during the troubleshooting process. Subsequently, a test drive is critical. During this drive, the technician should monitor the vehicle's operations, focusing on acceleration and overall drivability. On completing these tasks, ideally, no DTC should reappear, confirming that the original issue has been successfully resolved and the transmission is functioning correctly. To prevent future occurrences of DTC P0717 and maintain optimal vehicle performance, regular preventive maintenance practices should be established. Inspecting the wiring related to the torque converter turbine speed sensor routinely can help identify wear or damage, preventing failures before they affect the vehicle's operation. Additionally, using quality connectors during any repairs or replacements is crucial. Poor quality connectors can lead to corrosion or loose connections, causing sensor faults. The functionality of the torque converter turbine speed sensor should also be assessed periodically, particularly during service intervals or scheduled maintenance checks. Implementing these preventive actions can significantly enhance reliability and prolong the lifespan of the transmission system. In conclusion, DTC P0717 represents a significant electrical issue within the CVT input shaft speed sensor circuit, underscoring the importance of thorough troubleshooting focused on electrical integrity rather than mechanical faults. Addressing this DTC requires a structured approach, starting from initial diagnostics to going as deep as assessing connectors, circuits, and ultimately the sensor's functionality. By following the explicit steps laid out in the troubleshooting guide, technicians can effectively pinpoint the failures, subsequently implementing repairs where necessary. Additionally, ongoing and regular inspections of wiring and connection integrity are critical for the long-term performance of the vehicle. Committing to preventive maintenance will not only mitigate the risk of similar errors arising, but also ensure that the driving experience remains smooth and reliable. Please like and subscribe to the channel. See you next time.